Hello everyone. In today's session, we are going to discuss about Perceptron neural network model. Last session we have discussed about Hebbian model like HEPSNet, which follows the Hebbian learning rule, and it is just very simple procedure where we just take input pattern, present it, and update the weight. So whereas in Perceptron net, we are going to take the same like you will have a usual structure of feed-forward neural network structure. And here the algorithm works like an iterative process. So that's the difference between an HEPSNet and a perceptron net. The functions are going to be the same, but the way in which the network is trained, right, that differs. So perceptron is universally accepted neural network model, and it might be either a single layer network or a multi-layer network. So here I have shown you a single layer feed forward network, input layer followed by a output layer, and it is fully connected, and it follows Hebbian learning rule. So Hebbian learning rule is nothing but like you have this weight updation, right? See this weight updation formula. So this is the rule for learning. This is Hebbian rule is just to take t into xi, and here you are going to use an additional parameter alpha, or you can use nu also, any symbol that is going to be the learning rate. Okay, so this rule is followed over here. So we are going to follow the same rule as that of your HEPSNet, but the procedure alone varies. Okay, and here it is a feed-forward neural network, and it takes binary input, or input might be either binary or bipolar input vector, whereas your output is going to be a bipolar one. And here you have bias. As we discussed in Hebbian neural network model also, we have one unit of bias which takes always the input value as 1. To stabilize the net, we are going to use the bias. And you have a threshold value theta. Okay, so the learning rule is, this is the procedure for a perceptron learning network model. So what it do, you will be having a input set, right? Like you will have a data set which consists of your input parameters, or your x1 to xm, and your output might be either one unit, or it can have a multi-unit too. So here what I am going to do here is, for each and every input pair we are going to take, and we are going to calculate for each and every input pair. You are going to calculate what is your input that is received by this y. So it is summation of the input that is passed along with the weight vector. So it is x0 w0 plus x1 w1 plus x2 w2, and it keeps on going until xm. So it is summation of I is equal to 0 to m. So it starts from 0 to m, all weight multiplied by the input values. So this is the input that is received for this y. For each one single input pattern I am going to take, and I am going to present it to the net, and it calculates the input vector, that like input that receives for this y, and then it calculates the output. Output is nothing but the activation. Okay, so as I told you, your output is going to be a bipolar one. Bipolar ranges between either 1 or -1 or 0. So if it is greater than threshold, I am going to assign the value as 1, or equal to 0, or equal to threshold, it is 0. Otherwise, it is going to be negative -1 values. And then, so this procedure till now, it is common, right? Like what you have learned in your Hebbian net. In HEPSNet, what I do, I just assign all the x value, assign the target value here, and go for weight updation. But here, I take one input pattern, check what outcome it is going to get, and once after I receive this output, I am going to compare it with the target value that is there. So I am going to compare this y out with target value, and if there is no error, I am not going to update any weight. And if there is any change in between, I am going for this weight updation as per this Hebbian learning procedure. Okay. So when there is an error in the target, error between the target and the actual output it is produced, then I have to go for a weight updation. And if there is no error, no updation is needed. And this is iterated for all the input pattern. Okay, I take one pattern, do this procedure. Take the next input pattern, do the procedure. And it is not going to stop only for this input pattern. And this set of input patterns are again iterated. Okay, so once after I completed, like if I have my inputs as 1 to 10 input patterns are there in the in my given data set, I have to present each and everything and go for a weight updation. And finally, after completing all the 10, I have to start from 1 again. Okay, so when it is going to stop, this is called an approach. One iteration takes all 10 values to be learned. Okay, so 10 times this will be updated, and that is your first iteration. Next iteration, I have to start from the first pattern on. So it is learning. We are going to say keep on sending the pattern again and again and make sure that the network is learned properly. And how you are going to recognize it when the process is going to stop? For the entire 10 set of input, if there is no weighted updation is done. Okay, if there is no error, if all the target and your outcome is matches, then you are going to stop. Okay, if there is no error for the entire pair of this S and T, okay, S is your input vector and T is your output, then you can stop. Otherwise, we are going to continue this step again and again. Okay, so this is how a perceptron network works. So I'll show you with an example so that you'll understand it better. In the next video, we're going to meet with that example for perceptron net. Thank you.